Okay, so before we start the discussion, how about we introduce ourselves? Hello, my name is IZHAN.
Hi, I'm Ari.
Hi, I'm Kesha.
Hi, I'm Jess.
So today we will discuss about trigonometry. Hari, if you please.
Okay, let me just share my screen. Okay, so I'll be explaining a bit about its history and definition. So, trigonometry was actually derived from the Greek word trigonon, which means triangle, and metron, so triangle. But that was the main understanding of trigonometry. But later it found out that trigonometry is actually a branch of mathematics concerned with specific functions of angles and their applications to calculations. This basically means any calculation that involves angles, you will always use trigonometry. So to calculate this angle and all these lengths and everything, there are these 6 basic trigonometric functions that I'm pretty sure all of us know, which are sine, cosine, tangent, cotangent, secant, and cosecant. So a little bit about its history. Trigonometry was actually first used and discovered around the year 3000 BC by the Egyptians and Babylonians. The Egyptians actually used it to design the structure of the pyramids because the pyramid is triangular, they calculated the angle, structure. They found out that a circle can be divided into 360 degrees. So that was just like basic trigonometry. Trigonometry's golden age is known to be in around the 2nd century before Christ, when Hippocrates, a famous Greek mathematician, he found or made this thing called the table of chords. You see, the table of chords is actually something used for astronomy, and that was like the epitome of trigonometry. See, this guy Hippocrates was a Greek astronomer and mathematician, and due to his findings of trigonometry, he is named the father of trigonometry. So this is all like complex stuff. So let's go to like the basic 6 functions. So the basic trigonometric functions were actually discovered. The sine and cosine was discovered by an Indian mathematician named Aryabhata, whereas tangent was discovered by a Middle Eastern named Muhammad ibn Musa al-Khwarizmi. And cosecant was discovered by Abu al-Wafa Bujani. So this is a brief history about trigonometry.
So that's the history and definition of trigonometry. So now we will take a look the application of trigonometry in real life. Yes, Nita, if you please.
Thank you, IZHAN. Okay, I will continue with my presentation. Application in real life. So, firstly, astronomy. Trigonometry is used to measure the distance to stars in the solar system, the motion of nearby stars compared to more distant stars. So, as you can see here, application of trigonometry in astronomy. So, as astronomical unit is used for its unit. Okay, next one is C. Trigonometry is also used related to activities that involve C application. Thirdly, sport. Okay. There are 3 sports that using trigonometry in basketball, in rugby. Next one is soccer, and lastly, trigonometry is also used for makeup. Okay. How to contour your makeup? So trigonometry is also used in contouring your makeup. As you know that we have different shape of faces. Thus, if you want to change your shape face, so contouring is the best method to change your shape of face. Okay, this one, it look like this. When you want to contour your makeup, it must be 90-degree or 45-degree at your cheek, this one. Why? Because contouring trigonometry is very important for you to contour your face. The right angle is you must be you use the right angle to make your face beautiful, just like this at the left. So if you get the wrong angle, your face is look like this. But if you get the right angle, your face will look like the right one. This one. Okay? This is the advantages. So first, your face will look beautiful. Secondly, right angle will make your makeup look natural and beautiful. Lastly, thirdly, you can get the shape of your face that you want. For example, you want a square shape, oval shape, V shape. And lastly, you can save your time because you know the right angle for your makeup. Um, I think that's all for me. Thank you.
Now that's very interesting. Ladies will surely love
Wow.
the input. So now we will
Yeah.
take a look at problems that is occur in real life. So that's my turn. Yeah. Present.
So basically, how we use trigonometry in real life, is it?
Yes. What Hari said. Your entire screen je lah.
Yeah, now we can see.
Alright, good. Okay, so this is
Yeah.
the problem. How do we, determine the height of this building? I don't know.
I think we need to find out the distance first.
Oh, you mean this distance?
Yeah, the distance of the man from the building.
Okay, so next step. I think the next step we should, find the angle of elevation, right? You guys agree?
Yeah.
Yeah.
Okay, so like this lah.
Yeah.
Okay, so now what is the next step to find the measurement, the height of this building? The answer is we will use the trigonometry equation like so. So the formula is tangent theta equals to opposite over adjacent. So like this, we just substitute the value and then we will get this and then derive the equation. We should get AB equals to 9 times tangent 53.14. So if we key in the values into calculator, we should get mana calculator? The value 12, right?
Yeah.
Okay. So let's see if this is 12 meter. Wow. Trigonometry is amazing.
Yeah, we do. We
But
can solve this.
but this is not complete, right?
Yes, it's not complete yet.
So how do we like find the full length of this building?
I think we should add the height of the man also.
Oh, canggih. Okay. So we add. Uh, what should we get? What should we get? We should get 13.6,
We
right?
should
Is
get,
it?
Yes.
Wait.
Yang check.
IZHAN, why we use THAN?
Mana tu? We use tangent because the tangent. Kenapa ya? Because in trigonometry, tangent is equal to the opposite and over adjacent.
okay. So which is opposite and which is adjacent?
Oh,
This
okay.
it depends on the angle. If your angle is here, then the opposite will be CB. But in this case, the angle is ACB here, so the opposite will be AB. Okay, so now next we found the real height. So problem solved, right?
Yeah.
Yeah.
So
Yes.
basically we can use it to find the height of anything lah.
Yes. Anything can do. Mountain, satellite.
Ah, interesting.
Okay, so now next question, Hari, if you please. Kenapa ni rambutan cacat ni?
Okay. So we have a problem here.
Okay.
This is in the field of sports. So this guy here, he wants to throw a basketball from the free throw line. The free throw line is when you do a fall and you have to throw the basketball.
Tengah loading. Okay.
Okay. Okay, all okay?
Tanya je lah.
Okay.
Okay, so the problem we have here is this guy wants to throw the ball from the free throw line. So now we have to calculate the optimum angle so that every time he throws the ball, it will enter the hoop. Okay? So the information we have here is that the initial velocity of the ball is 5.4 meters per second, and the time taken for the ball to reach the basketball hoop is 1.3 seconds. And then we also have other information such as 4.5 meters. The free throw line is 4.5 meters away from the basketball hoop. The man is one.
But Harry, why U is equals to 5.4 amperes?
Oh, so I googled what is the average initial velocity of a basketball throw of people who play basketball, and I got that it's 5.4 meters per second. So that's like the average. So usually the people that throw the basketball, it's 5.4 meters per second.
Oh, I see that. Okay.
And then we also have that the time of flight is 1.3 seconds, something I googled also. Well, basically from the free throw line, which is somewhere around here, when you throw the basketball, it takes about 1.3 seconds to reach the hoop. So using this information, we can now find out, and then we have that information where the distance of the guy from the hoop is 4.5 meters. Of the initial velocity. How do you find Ux? Use the formula Sx equals to Uxt. So then we just put Sx. Sx will be 4.5. And then we have Ux, which we're trying to find out. and then we put in t, where t is 1.3 seconds. So using all that, then we get ux equals to 3.46 meters per second. So now that we have ux, so we have ux and u, we can now find out the angle at which he has to throw the basketball. Because we know that ux is equals to u cos theta. Equals to u, which is 5.4 meters per second, cos theta. Then we just move it around here and there. We get that theta is equals to 50.15 degrees. So the optimal angle to throw a basketball from the free throw line is 50.15 degrees.
Oh. But Hari, why do we use cos theta? Like I use tangent.
Why use cos theta?
Yes.
Oh, let me just illustrate it for you. Great. Okay. So let's just take this and draw it on a bigger scale here. So it's something like that.
Oh.
Okay.
Okay.
Meters per second. So basically, the length of this line represents 5.4 meters per second.
Okay.
So this is the horizontal component ux, which equals to, oh my god, it's so bad. Which equals to 3.46 meters per second. So this line represents 3.46 meters per second. So if we draw a line down here, we actually get it's supposed to be a right angle triangle. So since this is a right angle triangle, we can actually use trigonometry here. So to find this angle, okay, the information that we have is this line, which is 5.4, and this line, which is 3.46. So this is actually h, hypotenuse, and this is actually the adjacent, the angle A. Hypotenuse over adjacent. So the adjacent over hypotenuse is cos. So cos theta equals to the adjacent length, which is this line here, over the hypotenuse length. That.
Okay, thank you for that, Hari. So now we move on to the next question. Shasha, if you please.
Okay, so now I'm going to present about the astronomy. Okay, wait. Okay. Okay, you can see?
Not yet. On the way.
You can see?
Yeah.
Yeah, I can see it.
Yeah.
Okay. This one is about the question asks the distance between the stars and the Earth. Okay, this one X. You can see X. Okay, X. Okay.
Okay.
You can see right? Okay. And then the first step is we should know what we're gonna use. Is it tan, cos, or sine? Okay. So I'm gonna use tan theta because we know this one. We know this, and we know this 1 AU, and then we need to get this one. Okay, so I'm gonna use the tan theta. So tan theta is equal opposite to this one, opposite to adjacent. Okay, so I got 1 AU. Okay, 1 AU equals to AX. Okay, and then so So I'm on the spot anyway.
Oh, yes. Sasha, I have a question.
Okay.
What does AU mean?
Oh, AU is mean astronomy unit.
Oh, so it's a type of space measure?
Yes.
Like a meter lah. It's like meter lah.
Yes.
Yeah.
Okay, so we get here is tan theta equals to opposite over addition, right? And then this one kan X. Kita nak cari X. We need to find the X here. Right, okay. And then kita sub masuk. So X equals to X equals to 1 AU times theta. Okay, this one. Okay. We are between tan theta and X, and then I get this one. X equals to 1 up the theta here with this one, theta given, okay? And then we got 1 AU over time 0.0001, okay? So we get this one, right? And then we get the answer 1 AU divided by time 0.0012. We got 477 000 AU. Okay. If you calculate and you get this one. Okay, and then with this, we should change the AU, this one, this AU to LY. LY is light year, and then actually given out AU equals to 65000 light year. And then we convert this AU that we got here to the LY. We got 7.3 light year. Okay, so this one is the answer. This one is the answer for this. The X.
Oh, so Shasha, the 477000 just divide with 65, right?
Yes, just divide by that.
Okay, that's all, right?
Okay, that's all. Yeah.
Okay, so that's the 3 problems we have solved regarding problems with trigonometry in real life. So now we will conclude the discussion. Shasha, if you please.
Okay. Okay, this one. Okay, I will conclude. This one is the conclusion for the trigonometric function. Okay. Conclusion. We realize that trigonometry can be widely used in many areas, from astronomy to architecture, as they can aid in the conclusion. Without really climbing a tree, you can find the height easily with trigonometry. They can be so widely used in real-life applications and is very useful for most architects and astronomers. Second, we can conclude that without geometry, life would be much more difficult. Without going through the troubles, we can easily find the height of a building, so we think that it was a good invention by Hipparchus, and thanks to this, many architects need not go through the trouble to calculate unknown side of a specific angle, so it really helps in real life. It is very helpful in engineering career. So that's the conclusion for the trigonometric function.
Okay, that's all for this discussion. Thank you all for participating.
You're welcome.
Thank you juga.